Good day, everyone. Welcome to Physics and Mathematics Lovers. Today, we will be having a live broadcast. I want to learn this simple topic: density and relative density. So, we start by learning what density is all about, and also solve some examples and how we can determine the density of substance, solid, and liquid before we move to relative density. Okay. When we say density of substance, density is defined as the mass of that substance per unit volume. That means density is equal to mass over what? Volume. Which is equal to what? M over what? V. So density is a scalar quantity in the sense that it has no direction. It only has magnitude, which is the value. So now, when we determine the density of substance, we're actually looking at the ratio of the mass of that substance to what? A given volume of that same substance. How do we determine the density of solid, liquid, and that? But before that, the SI unit of density is, the standard unit is kilogram per meter cube. Or you can put it this way, which is kilogram per meter cube. This is the standard unit, the generally accepted unit for density. But we can also have grams per centimeter cube. These ones, we have other units, and this one is another unit of density. Now, how do we calculate the density of substances? For example, solid. We have solid. Now let's look at solid in the first place. To determine the density of a solid, you just need the mass of that solid and the volume of the solid. So how do you determine the mass? It's either you use what? Beam balance, or chemical balance to weigh the mass directly. So use beam balance or chemical balance to weigh the mass directly. Then you take note of the mass. Now the volume. So if it is a regular solid, you know, solid is divided into two. We have regular solid, and the irregular solid. So irregular. So the one I'm talking about here is the regular solid. To determine the mass, you weigh both regular and irregular. You weigh the mass by beam balance or chemical balance. But that of the volume of this the volume of this regular solid can be determined from its dimension, which is what? Length times breadth times what? Height. Or it could be the thickness of the material or the depth of that what? Solid. So this is determined here. This is the volume of regular solid. So in that case, after determining the mass, you just divide it straight by the volume. So you have obtained the density of that solid, which is what? Regular. But that of irregular solid, we can obtain the mass directly from what? The measurement, which is what? The beam balance or chemical balance. But the volume becomes a problem. How do we get the volume? It is gotten, the method we use is called displacement method. We call it what? Displacement what? Method. What does that mean? We have irregular solid. Now, because why do we say that you cannot determine it? Because it has no dimension. For example, something like a stone or a piece of wood that has no shape, which is what? Shapeless. How do we know the length? How do we know the breadth and the height? So it is impossible. So to know the volume now, we use what is called displacement method. Displacement method is either you use what? A measuring cylinder that is what? Graduated. So So when you use a measuring cylinder, you take note of the initial reading. Let's assume we have is filled with water. When the measuring cylinder is filled with water, now you put the objects that you want to measure the volume. The object will be placed inside. Let's say, for example, a piece of stone. You can just throw it inside. This is a piece of stone. So what will happen? When you look at the initial measurement, let's say this of V1, V2 at this point. So you take initial measurement, that is the level of that liquid that is poured inside the beaker or the measuring cylinder. So what you do, you record it, that is first reading. Then the next thing you are going to do, when you place the irregular subject, the volume of that liquid inside that measuring cylinder, it will increase. So you call that what? V2. Now how do you get the volume of this solid now that is just displayed? So what will be the volume? The volume of this solid now will be the amount of volume or the amount of water that is displaced by what? This irregular solid. In that case, to get that, we are going to have what? The final reading of V2 minus what? V1 minus what? Your initial reading. The initial reading is that level at which the water or liquid that was poured inside the measuring cylinder was. Now when the stone or an irregular object is then dropped into that measuring cylinder, so the volume of that liquid inside will rise up. So that's the kind of displacement. So it will not get to another level which is above the initial level. So therefore, to get the volume of that object now that is dropped inside that liquid, you will have to subtract the initial reading from the final reading. So in that case, you have gotten the volume. So at that point, you can calculate the density of the solid by what? Mass over what? Volume. So that is it for regular and irregular solid. So what you just need to know there is how to determine the volume and also determine the mass. Now what of that of liquid? Liquid is very simple. Well, having known the mass of the liquid, we use, or there is a bottle, that is what? A density bottle that we just use for liquid. Yeah, that one is graduated and is designed for only measurement of density. That is for what? Solid. That is for liquid rather. So when you just pour it there, the level at which the liquid gets to is what? The density of that liquid. And the density bottle is graduated in what? Either gram per centimeter cube or kilogram per meter cube rather. So that is about that. So we want to solve one or two examples on density before we can move into relative density. So we'll be taking it one after the other. So I have a question here. Let me write it on the board so we can calculate it together. It's very simple. The key thing for you to understand here is to just know the mass and know the what? The volume, then you calculate. Here I have we say a block of ice. As example, a block of ice with volume 5.5 meter cube has a mass of 5,060 kilogram. Find the density of ice. Find the density of ice. Find the density of ice. So this is very simple. From all my illustrations, the illustration that I gave earlier on this topic, density, what we just need is the mass and the volume, and it is clearly written here. So solution, bring a solution. So your solution now, what you do, you must state out the parameters. State out the parameters. So now the number one thing we are giving you a volume of what? Block of ice. So we just take note of what? Volume. Your volume is equal to how many? We have a 5.5 meter cube. The next one is the mass given. So you write your given here. So this is your given. The mass is equal to 5,060 kilogram. So you can quickly recall your density. The formula for your density is equal to mass over what? Volume. Mass over volume. So our mass here is what? 5,060. Then volume is what? 55.5. So just simple division and you get your answer. So let's press calculator and divide this now. So at the end of the day, we are going to have, after pressing your calculator, you are going to have 920. So yeah, it will give us for 920 kilogram. Don't forget kilogram per meter cube. So this is your final answer. So this is your question number 1 on density. So do not forget, when the units must be in what? Kilogram per meter cube. But it all depends on the parameter that I give it to you. If the volume is given in centimeter cube and the mass is also given in gram, so you can leave it in gram per centimeter cube. But the standard unit must be observed, which means you are going to convert everything. Maybe at the end of the day, after your calculation, you convert it to kilogram per meter cube. Now let's look at another question now in a different version. So let's look at it in a different way that will require you to use your mental arithmetic. So let's go. So let me clean this one. I have to clean this. So let me read the question. You have the question here, right here. The question reads: a silver cylindrical. That is example number 2 now. Let's go to example number 2. Example number 2. Okay. All right. And it says, a silver cylindrical rod has a length of 0.5 meter and a radius of 0.4 meter. Find the density of the rod. Find the density of the rod if its mass is 2,640 kilogram. Is 2,640 kilogram. Yes. This one is another question in different form. Remember, a cylindrical rod is also a solid. So we are just working on solid now. So maybe the next example we are going to digress to liquid. Now, solution. Remember what we need when you are calculating density. You just need the mass and the what? Volume. So given, we have mass. Mass is equal to 2,640 kilogram. But the volume, we don't know the volume. How do we calculate the volume now? Volume of cylinder, you have to use the formula. That is why you have to come, you bring your mathematical knowledge. Volume of cylinder. Who can remind me the volume of cylinder is what? Pi r square h. Pi r square h. That is the formula for volume of what? A cylinder. So now at this point you need to calculate the volume, then use it to divide that of mass. Divide the mass so that you can get your answer straight. So now let's go. Substitute all the values. We'll say that what? radius here. We are given that radius here, which is R, is equal to, look at it, 0.4. 0.4. Now this length now we are talking about now is the height of that of cylinder. So the cylinder is usually like this. So when it is like this, that is the base. This one could be the base. So this height here, from here to here, that is the length we are talking about now, which is your height. So what we do now, you put your length, which is height, equal to what? 0.5. 0.5. Okay. So let's solve it here because of space. Okay, I don't know if you can see below. All right. So now let's solve. Let's go up here. Yeah. The volume now will be equal to what? We have pi. Remember, the value for pi is what? 3.14. Pi, what? 3.14. Or you can simply use 22/7. But let me use this. I'm working with decimal already. Let me not include fraction again. Let me just use all this formula. So at the end of the day, we have what? 3.14 times our radius here is squared. So 0.4 all squared. Then times, what is our length, which is the height? 0.5. Now let's evaluate all these things. Let's multiply everything together. Use your calculator. Take your calculator and multiply all of them. What will it give to you? Now somebody do that now and give me the answer. Okay, the answer says 0.2512. 0.2512 meter. Remember the meter cube. This is your volume now. So the question is almost going to an end. Now we have calculated for the volume. The next thing now, you bring your formula for density. Your formula for density is mass over volume. So your density now, density is equal to mass over volume. So now at the end of the day, we have our mass to be 2,640 over, what is our volume we just calculated? 0.2512. So and let's divide, press your calculator. So use the calculator now, let's divide and get the answer. So that the answer will be in kilogram per meter cube. So finally, our answer now says, okay, 2,640 divided by 0.2512. We have, okay, 1,000. Okay, we have 1050. That is 10,000. 509. So at the end of the day, your density now is equal to 10,509 kilogram per meter cube. This is the answer to your question number 2. So now let's check if we can still have another question in different way. Let's see if we can bring out question from different angle. Let me check here if I have another question. Okay, let's look at example number 3. Example number 3. Let's look at example number 3. Example number 3. The question here says, example number 3, say a stone has a mass. Okay, number 3 says a stone has a mass. It has a mass of 112.5 grams. Has a mass of 112.5 grams. When this, okay, when the stone totally immersed, in water, containing the water contained. Okay, water contained in measuring cylinder. Yes, like the illustration I gave you before. In measuring cylinder. In measuring cylinder displays. Measuring cylinder displays water. Displaced water. Displaced water from 0. Okay, from 50 cm cube. From 50 cm cube. From 50 cm cube to 95 cm cube. Find the density of the stone. Find the density of the stone. Find the density of the stone. Yes, this is a simple one. So from my illustration, while I was telling you how we can determine the density of irregular solid. Now, stone is an irregular solid that you cannot determine the volume by what? Calculation. So what you do is just what? Displacement method. Now let's go to solution. Now state out your given parameters. Which one and which one is given? Okay, we have a mass of the earth, the stone. Mass of the stone is what? 112 points. Okay, look at it here. Mass of the stone is what? Mass is equal to what? 112.5 what? Grams. So now the volume. Now remember I told you volume displays. You take the final reading minus what? The initial reading. Now the volume of the stone. Now volume. Now the volume we are going to use now. Volume will be equal to your V2, which is your final volume, minus what? Initial volume, which is your V1. Look at it here. They say, it says a stone has a mass of what? 112.5 gram. When the stone totally immersed in water contained in measuring cylinder displaced water from what? 50 cm cube to what? 95 cm cube. What does that statement mean? It means that what? The initial reading of that the volume of water in that cylinder when the stone has not been dropped into that water is what? 50 cm cube. So that was what I explained earlier. Now when the stone is now dropped inside that water, the volume rises. So the volume would rise to what? 95 cm cube. So how do we get the volume of that particular solid? So it was the solid that dropped, which is this stone, that caused the rise in that volume. So to get that volume, which is displaced, the volume displaced by that stone will be 95, which is our final volume. 95 minus what? 50. So 95 minus 50 will give you 45 cm cube. So your V is equal to what? 45 cm cube. So this one is the volume of the stone. Now you can gladly calculate or easily calculate your density. Now what is the formula for density? It's what? Mass over volume. So let's finish it up here. So your density equal to mass over volume. So what is our mass? Our mass there is what? 112.5 grams. Then all over 45. So this is your density. Very simple. Use the calculator and get it. So what will be the answer? Remember, since the unit is already in gram and a centimeter cube, you don't need to convert. But if you are told otherwise, you can change it to what? Kilogram per meter cube. Okay. Now at the end of the day, when you divide, you are going to have 2.5 gram per centimeter cube. The density will now give you equal to what? 2.5 grams per centimeter cube. So that is the answer. 2.5 grams per what? Centimeter cube. You can see that density can be calculated in various ways. So I will stop at example number 4. So for today, maybe in our next class, we will continue from there. But I have one example to solve, one more example. Okay. So this one more example I'm going to solve. Then maybe in the next class we will treat relative density. Okay. So number 4 here says beaker contains. Remember I told you density questions can be brought in different ways. You can bring it in a different way, but provided you know the concept. The basic concept says mass over volume. Now let's look at this question. Beaker contains, we have 2.5 cm cube of a certain liquid. Weight liquid weight 410 grams. Liquid weight 410 grams. So if the mass of an empty dry, if the mass of an empty dry beaker is 200 grams. Find the density of the liquids. Find the density of the liquid. Yes, somebody is getting confused. Don't get confused. Don't be confused. Remember I told you, it's just the mass per unit volume. So whatever question that is given to you, you are going to determine the mass, then you look for the volume. So the volume there is very simple, it's very clear. So it's very clear. Okay. So the volume there is very clear. Let's go to solution. Okay. Now number 1 thing that is given to us here, before we look for the mass. How do we get the mass? So somebody is confused here. Someone is confused. Mass now. Say a beaker contains what? 262.5 cm cube of a certain liquid. The liquid now weighs, for example, this is a liquid. Okay. The liquid weighs what? Ordinary liquid like water. We don't even know what liquid is. So it weighs what? 410 grams. So if the mass of an empty dry beaker is what? Is 200. Okay. So the mass of the empty dry beaker is what? 200. Now how do we now know the mass now? It's very easy of that word liquid. Now they say the beaker contain this, which is what? 200 and what? It contains what? 262. This is the volume of that liquid inside that what? Beaker. And now the total, both the beaker and the liquid inside here, that is the beaker. For example, let's say this is the beaker. Now it means I have liquid now. Both this liquid and the beaker, it is weighing equal to 410. But only beaker weighs 200 grams. Now, how will I know the mass of this liquid inside that beaker? It's very simple. I will just subtract this 200, which is what the empty dry beaker, from the total of what both water and what, or the liquid and the beaker all together. So I will just subtract it. I will just say 410 minus what? 200. So 410 minus 200, it will give us what? 210 grams. Equal to what? 210 grams. So very easy. So we already know the volume. The volume is equal to what? 262.5 cm cubed. So your formula for density, you remember, just volume over what? Okay, mass over volume rather. So let's finish it up here. So mass over what? Volume. So here we're going to have your density is equal to what? Mass over volume. We already know the volume, we already know the mass now. So at the end of the day, we are going to have what? 210 over 262.5. Now let's punch our calculator and get the answer without wasting much time. Okay, 210 divided by 262.5 is going to give us 0.8 equal to 0.8 gram per what? Centimeter cube. Do not forget, this is what? Gram per centimeter cube. So if you want to convert, you multiply this and divide by 10 raised to power, that is 100 raised to power 3. So we are not converting, we leave the answer like this. So we leave the answer, since the answer is in gram and already is centimeter. So we leave our answer like this. If you find this class very interesting, please comment. Sorry. And also today we have to look at the relative density. When we talk about relative density, we are actually comparing the densities of two substances. Yes, for example, if I have a particular substance and I wish to compare the density of that substance to another, so we call that what? Relative density. So it's quite different from the other type of the main density we are talking about. But today, let's look at the general definition of relative density. So, relative density of any substance is the ratio of the density of that substance to the density of what? Water. That means the ratio of density of that substance now. That is to say, density of substance now all over density of what? Water. So another name for relative density is also known as specific gravity. So when some textbooks call it specific gravity, you don't need to be confused. So it's also talking about relative density. Now, since we said our density is talking about weight, you can also say that this relative density is equal to weight of substance in air. That means substance in air all over weight of that substance in water. Weight of that substance what? In water. So that is another definition you can use for relative density. And another way, since we said about density, we are dealing with what? Mass. We are dealing with mass. So we can also say that the mass of that substance in air. Say mass of the substance now in air all over what? Mass of equal volume of water. Mass of equal volume of water. So these formulas are used to calculate the relative density of a substance. So it doesn't matter, or it all depends on the parameters that are given to you. We consider what? The density of what? A substance. The relative density of a substance is the ratio of the density of that substance to the density of what? Water. So you can call it that way, or you say relative density of a substance is the ratio of mass of any volume of that substance now to the mass of an equal volume of what? Water. Yes, since density of a substance is dealing with what? Mass and what? Volume. So the mass of any volume of that substance now, then to the ratio of a mass of equal volume of what? Water. That is the relative density. That's how we can calculate it. So mass of any volume of substance all over mass of equal volume of water. Since mass is proportional to the weight, we can also say that weight of any substance all over weight of an equal volume of what? Water. That is what? Relative density. Remember I told you. So we have decided to take water as a general standard for comparing the densities of other substances. When I told you, I said that relative density try to compare density of one substance to the other. But in physics, we decide to make use of water as a general standard for what? Determining the what? The relative density of what? Substance. So that is for that. Now let's just do one example. Then before we go to determination of densities of granules and sand. So let's know how we can calculate that. So I have a question here. So I will clean the board. So why I write the question. So I have a question here to solve. So as to the question here says a globe, that's question number 1, a globe of steel has a mass of 12 grams and a volume let's continue here, and a volume of 15.2 cm cube. They ask us find its relative density. Find its relative density. So now, solution. How do we get this now? From the definition I've given to us. So we have different formulas we can use. Now, how do we get that now? Well, let's make use of relative density as equal to mass of any volume of that substance equal to the mass of an equal volume of water. So, solution, you must state your formula, relative density now. We call it, or let me use RD. RD as a short form. So I will say the mass of any volume, the mass of any volume of substance of this T here, substance, all over mass of an equal volume of what? Water. Mass of an equal volume of water. Now we are given the mass of that solid. That your mass there is what? It's equal to 12 grams. With 12 grams, then your volume is equal to 15.2 cm cube. Now, how do we now know the mass of an equal volume of water now? So we have to use our sense now. So therefore, since mass of 15.2 cm cube of water. Now, since mass of 15.2 cm cube of water is equal to, now from there, remember we are comparing it to the density, a mass of equal volume of water. So what are we going to do now? So that means the mass of 15.2 cm cube of water is going to be 1 gram per centimeter cube of the density. That means we said our density is equal to what? Mass over what? Volume. Now, since we say the mass of equal volume So for here, we said our mass of equal volume of water means that we are going to compare the volume of that same substance now. So that of water. So the density of this space now will be on 1 per cm, that is on 1 gram per centimeter cube. Now, since we say that what density is equal to our mass over volume, so for us to get the volume here, we are going to multiply this one by the mass, which is what 15 points. This 15.2 cm cube. 15.2 cm cube. So this will now give us the volume of the water we are going to make use of. So to get the volume of the water now, volume of the water will be equal to 1 gram per cm cube times that 15.2 gram. So at the end of the day, you still going to give us what 15.2 gram. So that is the mass of what the water we are going to use. So now relative density is just straightforward. We said our mass of any volume, and the mass of any volume of that water is what 12 kg. Okay, 12 grams rather, 12 g. So here, so the relative density now RD is equal to what the mass of any volume of that what substance, which is what 12 gram. We're going to have what 12 gram all over 15.2 gram. So this is our relative density. So we are going to the gram and gram will cancel out. So relative density has no unit. It's a ratio of two masses. So we divide 12 divided by 15.2. It will give us what 0.79. Remember I told you relative density has no unit, because it is a ratio of what two masses. Mass of any volume of that substance, then to the volume of what equal that the mass of what equal volume of water. So that is for that. So let us look at how we can use this density now to measure the relative density of solid now. So let's use it at determination of densities of granules and this sand. Let's go to that place. Let me clean the board. When you bring the density bottle like this, when you bring it, then you first of all weigh it. When you weigh it, the empty and dried one, so you call that the mass, MO. Or when you calculate the density, it becomes what? That is what MO, or yes, let's use MO. You can measure it in gram. So the next thing you have to do now, you put some granules or find the mass, put the solid you want to use, you want to determine the density. You put it inside the bottle, then it will now be equal to what M1. You call that one, and you weigh both the density bottle, mass of the empty bottle plus mass of what the stone. So this one is the mass of what empty bottle. This is the mass of the empty bottle. Now when you put stone inside, you have what M1G. This one is equal to mass of empty bottle plus mass of what the object, which is your solid. Let me say stone. So that is that. So we call this what M2. So this is your M2, or okay, M1 rather. M1. Sorry, M1. Then the next mass we are going to look at now again. We are going to pour water in the bottle until it is full, and we'll find M2. So we pour water into that bottle again, then until it is full. So we now have a mass of the bottle plus mass of granules or plus mass of water. So in this case now, we are going to have an M2G. So this one is going to be what 3 masses now. It's going to be mass of the bottle, mass of what bottle, plus mass of the stone, let me say stone or granule, then plus mass of the water. Mass of what? Water. So we have 3 masses now. Here we are going to determine the density of this object now. So how do we determine this density now? So we have been able to take this now. So the mass of the sand now, either sand or the stone. So how do you get the mass? You're going to be what the M1 minus what MO. That means mass of the sand itself is going to be what? From here, you are going to remove this MO from this what? M1. So we are going to have a mass of sand is equal to what? M1 minus what? MO. So remember the unit is in what? In grams. Now the next thing we are going to determine again now is to look for the mass of that what? Water. So how do we get that now? Okay. So mass of sand is that now. So mass of water above the sand now. So we need to get the mass of water above the sand. So it's going to be what? M2 minus what? M1. That means mass of water filling the bottle. So now the mass of water now that is above the sand. You need to get that mass again. Mass of water above the sand. So we are going to have M2. So mass of water above sand is equal to what? M2 minus what? M1. Remember it's in gram. So we are going to ask for another mass now. The mass of the water that is filling the bottle. So the mass of water filling the what? The bottle. So we are going to have mass of water filling the bottle. It's going to be what? M3 minus what? M3 minus what? M2. All right. So that is how we are going to determine the density of this sand. So at the end of the day, we are going to have a general formula that we are going to use. So now we have M2 minus M1. Then the other one there is what? The mass of the water filling. Remember, you have to find the mass of the bottle filled with water. We're supposed to have written that. So we have the mass of the bottle filled with water now. It's going to be mass of bottle plus mass of what? Water. So we have M3. Our M3 is one mass of bottle filled with water. So now the mass of what? The mass of water now filling the bottle. Filling is equal to what? M3 minus what? MO gram. So from here, we are going to determine the relative density of this substance. So how do we go about that? Now, since density of water is what? 1 gram per cm cube. So volume of sand now, we are going to calculate volume of sand. So since, let's clean here. Since, remember, we need volume. So mass of any volume of any substance all over mass of equal volume of water. That is our relative density. Now, so for us to get the volume of the sand now, volume of sand now is going to be what? M1 plus, that is the total mass there, the mass of that what? Empty bottle plus that M3 minus, so we are going to have volume of sand is equal to what? M1 plus M3. Yeah, this one is a mass. Then minus this one, M1. You're going to have what? MO plus what? M2. So we have MO plus what? M2. This is total mass. So we subtract this one. This one is our volume. We are going to use that as the volume. Then remember, it's going to be what? 1 gram per what? Centimeter cube. So therefore density now is equal to mass over volume. We already know that. Density is equal to a mass over volume. And now remember, all these ones we are talking about is now the what? The volume. So density is equal to mass over volume. We already know the mass of what? The solid as what? M1 minus what? MO. That is what? The empty bottle. So density of sand now is going to be equal to. So density of this sand now, of sand, is equal to what? M1 minus MO all over M1 plus M3 minus MO plus what? M2. Remember, this one is going to be gram per centimeter cube. This is density. I'm not talking about relative density yet. So this is how to determine the density of substance using relative density bottle. So we use this formula to calculate the density of what? That substance. So we are going to solve one example with this formula. So we are going to solve an example with this. So how you can be able to what? To calculate the density of, let me say for example, sand or a stone with a density bottle. You use what? Relative density bottle. So let's look at example 1 here. We have given the data below. Okay. All right. So let's look at example 1. It says, given the data below, find the density of granules, mass of empty dry density. Okay, let me copy the question on the board so that we will understand it. So let's use it to evaluate this. So this is the formula we use to determine the density of what? Any solid substance like sand, stone, or granules from what? Relative density bottle. So we use this one. This is the formula we use to determine. In case you are given a question on this, so you should be able to bring out this formula. So all those processes I went through was to just derive this very formula. So now let's solve one example with this. So if I solve one example with this, then on your own you can go home and try. So look at what? Example 1. Example. Say giving the data below. This is how the question is given. Give the data below. Find the density. The density of granules. Density of what? Granules. Density of granules. Now look at the data below. We have a mass of empty dry density bottle. Density bottle equal to what? 18 gram. Now they say, well, mass of density bottle and granules. Now that means both of them, when the granule is now put inside the bottle, mass of density bottle, mass of density bottle and granules is equal to 131 grams. So here we also have a mass of density bottle and granules together. Mass of density bottle and granules together with water on top. With water now on top is equal to 171 gram. So mass of density bottle now filled with water again. Remember that M3. Mass of density bottle filled, okay, full of water rather. Full of water is equal to 68 grams. So now, from all our education, this one here is our MO from my derivation. Then while this here is our M2. So this very one here is our M3. Okay, so let's look at how we are going to solve this question. Now, the formula says we are going to use this formula that says, okay, let's use this formula, density of sand now. That's it, density of sand is equal to the formula we wrote. We have M1 minus M4 all over M1 plus M3, then okay, M1 plus M2 rather. We have what M, yeah, we have minus rather. We have minus M2 plus M3. So we use this formula now. Let's plug in those objects. Let's plug in those parameters. Let's plug it in. So let's plug it in. Oh, the weather is very bad here. What are we going to do now? The weather is really, really bad. So now let's substitute. Where's our M1? So our M1 there, remember this one is in gram per centimeter cube. Okay. So your M1 minus MO, your M1 here is what? This is your, okay, this is our M1. M1, this is your what? M2, and this is your what? M3. So now, let's go. We have M1 is 131 minus, where's our MO? Minus 18. Then over, where's our M1? Okay. So now let's go. Let me get calculator so that we can just punch it. We don't want to waste much time. Let's get rain, please. Oh, rain. The weather is really, really bad here. Rain is disturbing and it's just breaking. Okay. All right. So we go. This is okay. This is the formula that I stated earlier. We have what? M1 minus MO all over what? M1 plus M3 plus here is the total mass. So when you determine the volume, so this one stands our volume is in centimeter. So what you do now, you just plug in the values. You have 1 minus 18. Minus 18. Then next one we have 131. What is our M1? M1 is what? 131 plus M3 is what? 68. 68. Then plus. Okay. We have 1. That's the 18. That's M4 is what? 18. 18 plus M2 is what? 171. So let's evaluate up. So let's just use calculator and get everything at once. Okay. So let's go. Let's get a calculator. Let's just add everything together. Yeah. Get our answer straight. Remember, this one is minus, it's not plus. Sorry. It's minus, so we have to be very careful. This is physics calculation. Okay, at the end of the day, what we are going to have, let me press it here, let me calculate it here. I'm going to have, remember density is the general. Okay. We're going to have 11300 kilogram per meter cube. So this is our, after space of conversion, this is our final answer. So if you found this class very interesting, don't hesitate to share and comment. So we'll be going on live for some time. So this is physics and mathematics lovers. So the general formula there is for using a relative density bottle to determine the density of what? Solids, irregular solid rather, like sand, stool, granules. So first of all, determine the empty density bottle. You weigh it, you call it what? M0. So gram, that is what the mass of it. So you also determine the mass of the granule. Now when you have put it inside the bottle, it will give you what? M1 gram. Then mass of the density now plus bottle plus granule, then fill it together with water. So to give us what? M2. Then you empty the bottle again, then you fill mass of the full water. That was the water alone with the density bottle. You fill it to give us what? M3. So to get the density of that sand, it was M1 minus M0 all over what? M1 plus what? M3 minus what? MO plus what? M2. So at the end of the day, after calculation, we did conversion. This particular formula is in what? In grams. So after calculation, this one will be converted to what? Kilogram per meter cube. That is the final answer. Thank you for watching. God bless you.